let's discuss about polynomial functions. To be particular, the introduction of polynomial functions. So this is the general form of your polynomial function. The general form of your polynomial function is a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus a sub n minus 2 times x raised to n minus 2 plus many more individual parts. Okay. Until we've reached a sub 1 times x plus a sub 0. Wait, hold on. Plus a sub 0. Nope. Wait. There we go. Now, if you would take a look at this one, you will not understand this, especially if you're a type of guy who have problems in what do you call this one, in understanding mathematics. Especially for this one, you will not understand this. All right. So what does this mean? Okay, this is the general form, but yeah, what does this mean? Okay, so before that, let's discuss the parts first of a polynomial function. Okay, so what are the parts of a polynomial function? Or yeah, it's still parts. Yeah, so let's discuss the parts. So these individual terms, these I actually mentioned it already. But yeah, these individual parts, okay, this one, a sub n raised to x sub n, a sub n minus 1 times x raised to n minus 1, and so on and so forth. These individual parts are what you call as your terms. Okay, these are what you call your terms. So let me give an example. We have f of x is equal to x squared minus 2x plus 1. So your x squared, negative 2x, and your 1 are what you call as your terms. Okay, these are your terms. All right, these individual parts, this x squared, negative 2x, and 1, these are your terms. Okay? To be particular for a moment, how about this one? We have 1 here. And as you can see in the last part, we have a sub 0, right? This a sub 0, as you can see, there is no x, right? As you can see, there is no x here. So this one, if there's no x here, you call this one as your constant term. Okay? So let's relate it in this example. Right? We have 1 here. And as you can see, 1 is just a real number. But there's no x. There's no letters involved. So this is your constant term. So why is it called a constant term? It is called a constant term because there is no x. Okay, there is no x. Only number. Okay? So if you see a number only and there's no partner of variables or x, then it is just a constant term. Okay? Now, what do you call, wait, before that, let me erase the parts of this one. I mean, sorry, let me erase this. Okay? Because we're going to proceed to the next part. Now, as you can see, if you're going to observe them, right, we have a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus a sub n minus 2 times x raised to n minus 2, and so on and so forth, right? So these are grouped together, right? They are all grouped together. So what do you call this group of terms? Okay, since these terms are grouped together, what do you call this one? So this is what you call as your expression. Okay, this is what you call as your expression. So here we have x squared minus 2x plus 1. They are grouped together in one side, right? So this is what you call as your expression. Okay? Now, let me give you one more example. Let's just say I have this format. Let's just say, again, it is just an example, okay? So I have x squared minus x plus 5 is equal to 2x cubed plus 4x squared minus 2x plus 1. Okay? Now, let's take a look. So, again, individual parts, 2x cubed plus 4x squared minus 2x plus 1, x squared, negative x, and positive 5. These are what you call as your terms, right? But what if they are grouped together in one side? So if they're grouped together, this is what you call as your expression. So the same thing on the left side, x squared, negative 2x, and positive 5 are grouped together. X squared minus x plus 5 are grouped together. So if they're grouped together, what do you call this one? It is just an expression. Okay? So now that you know the main parts of a polynomial, now there's one thing that you need to know. Okay? What do you call the whole part of this one? The whole part basically. Okay? Wherein there is an equal sign. Okay? If you see an equal sign, okay, what do you call this one? That is what you call as your equation. If there is an equal sign in between them, there is what you call, that is what you call as your equation. Again, if there is, what do you call it? If there is an equal sign in between them, okay, so that is what you call as your equation. Okay, the same thing here. Of x is equal to x squared minus 2x plus 1. And the same thing here, f of x equal to a sub n times x and yada yada. And the same thing here, x squared equal to 2x cubed plus 4x squared minus 2x plus 1. That is what you call as your equation. Okay? So basically, these are just parts of your polynomial. Okay? Now, let's go back to the topic. Now that we've already discussed it, now let's talk about the format of your polynomial. Okay? Let's take a look at this one. Right? I mentioned earlier that you don't understand this one. Okay? Unless you have this mathematical skill that you can analyze easily and you can understand it better than other people who have problems in mathematics, then congrats to you. But now let's talk about this one. You see the format a sub n times x raised to n, right? Then to the next term or your second term, we have a sub n minus 1. And then to the third term, we have n minus 2 and n minus 2, right? So meaning, okay, as you can see, we're talking about the exponent here. Let's take a look at this one. This is your first term, x squared, right? Then on the second term, what is the exponent? The exponent is 1. And then what's the exponent in here? Since it is just a constant, so the exponent of your x here is 0. Now, let me give you one more example so that you will understand it even more. So we have another function. Let me use different letter. G of, let's just say Z. Okay, let me use different letter. So we have Z cubed plus 2Z squared plus 3Z plus 1. Now take a look at the exponents. We have 3, 2, and for here we have 1. And since we have your constant here, which is your 1, then we will have 0. So as you can see, from 3 to 2, from 2 to 1, and from 1 to 0. So what did you observe? The exponent is decreasing one by one. That's basically another way on how would you explain the general formula or the general form of your polynomial function. So the exponents are decreasing until you reach 0 or at least the lowest exponent. So you must reach until 0. That's it. Okay? So what if I have another function? H of x is equal to 3x squared minus x plus 1 plus 1 all over x. Now let's take a look. Look at the exponent here. So we have your 2, we have your 1, and here, since it is just a constant term, this is 0. However, how about this one? What is the exponent for this one? So recall, if you're going to recall your lessons in algebra about exponents, if you have this one, 1 all over x, right? The exponent of x is always 1, right? If there's no given exponent, only x, then the exponent itself is 1, right? So if you're going to make it as a whole term, this would be x raised to negative 1. So therefore, the exponent of the last term is x raised to negative 1. Okay? That is the exponent of 1 all over x. So we can rewrite this. We can rewrite this as x raised to negative 1. Okay? Because 1 all over x or x raised to negative 1 are both the same. Now let's take a look. We have 2 from 2 to 1, 1 to 0, and 0 to negative 1. Okay? Now let's go back here. Right? We've reached until a sub 0. Meaning, we will reach until the constant term. However, the last term here is not constant. We have x raised to negative 1. Okay? So meaning, this is not a polynomial function. Okay? Why? Why do you think that it is not a polynomial function? Because the last term has a negative exponent. Okay? Therefore, that is not a polynomial. Okay? Polynomial should end at least, what do you call this one? At least the exponent that is greater than 0. Okay? Take a look at this one. From 3, from 3 to 2, from 2 to 1, from 1 to 0. So if we reach until 0, okay? So this one, if it reaches until negative 1, so no. No negative exponent is allowed, basically. To simplify things, no negative exponent is allowed. Only from positive number until 0. That's it. So no negative exponent. Okay? So how about this one? Okay. Let's just say I have h of x is equal to 4x cubed minus 2x squared plus 1. So as you can see, take a look at the exponent. We have from 3 going to 2. Then here, since it is just a constant, the exponent here is 0. Okay? So take a look. Is this correct? The answer is yes. This is a polynomial. Okay? How about another one? Let's just say I have j of x is equal to x raised to 4 plus x squared. Now let's take a look. Is this a polynomial? Let's take a look at the exponent from 4 going to 2. So is this correct? The answer is yes, it is still correct. So what can we say? We can say that the uh, the exponents involved in a polynomial should be what? Should be positive or at least 0. So 0, positive 1, 2, 3, 4, and so on and so forth. These should be the rule, number one rule for the polynomial function. There shall be no negative. Remember earlier, right? We saw a negative exponent. So if we see negative exponent, at least one of them, then that is not a polynomial function. Do you understand me? Okay. Now let's go to the last part of this discussion, which is the arrangement. Okay. So if you would take a look at the standard form, or general form, look at this one. Let's go back here. Okay. So if you would take a look, right, we have from n going to n minus 1 going to n minus 2, right? So basically, the arrangement of the terms should be in descending order. But what would be the basis? The basis is the exponent of your independent variable. Okay? So, from the highest exponent until the lowest exponent. So, take a look. Look at here at the function f of x. It is in descending order from the highest, which is your 2, until the lowest, which is your 0. Okay? So, 0 for your constant term. Okay? Now, let's go back to g of z. We have the highest exponent of 3 until we've reached the lowest exponent of 0. So, it is in descending order. From highest, second highest, third highest, until we've reached the lowest. So how about this one for j of x? From 4, the highest, until the lowest 2. So that's it, from your highest exponent until the lowest exponent of 2. So you see, it is what? Descending order. From highest exponent of your x until the lowest exponent of your x. So that is the arrangement of your polynomial. So let me give you an example though. Let's just say I have two functions. I have h of x is equal to x cubed plus x squared plus x minus 2. Then I have this another function, okay, which is g of x. So this one is in like this format, x squared plus x raised to 4 plus x cubed, hold on, plus x cubed minus 1. So which one of them is in correct arrangement? Is it h of x or g of x? So you see, h of x has the correct arrangement because it is in descending order from the highest exponent of 3 until we've reached the lowest exponent. So the exponent here for the constant is 0. So again, it should be from the highest to lowest. This one, on the other hand, it is not properly arranged. It's jumbled. So what are we going to do? We're going to arrange them. So let's start from the highest exponent. So which one is the highest? Right? This one, right? So we will have x raised to 4. Next, what is your second highest? Your second highest is x cubed. Okay. What's your third highest? X squared. And lastly, your constant, -1. Now let's take a look. Your highest is 4 until you've reached the exponent of -1, which is 0. So you see, it is in descending order from highest up to the lowest. And that's how you should do it. Okay, that's how you should do it. All right. So yeah, basically this is just the introduction of a polynomial functions. So I hope you have learned something else here. So first thing is basically the parts of a polynomial function. The second thing is about what do you call this one? What's this? I kind of forgot the second part. What's that? The second part, I guess it's about like the arrangement, right? The arrangement. Yeah, the arrangement itself. Then the last part is basically the exponent. Hmm, I don't think if I remember correctly. But as long as you understand what I mean, guys, that's all it matters. And if you listen properly to what I'm trying to say and point out, then you will understand what I mean to say. Actually, now I remember. The first part we discussed about the parts, right? Then the second uh, part that we discussed is about the exponents, right? There should be only positive exponent, at least zero exponent, from zero up to positive exponents. Okay? From zero up to positive exponents. Then on the third part is about the arrangement, just like this one, from highest exponent until the lowest exponent. So yeah, that's basically it. That's the introduction of polynomial functions.